All right, so we are starting chapter 9 today. This is our last chapter on pointers. This might be one of the more difficult chapters just because, just the idea of pointers is just usually kind of a hard concept to get, but hopefully it won't be too bad. Okay, so we've been kind of working with pointers all along. We just didn't know that we were doing that. So we were using reference variables, and if you were to print a reference variable like this with the ampersand, so we talked about that ampersand before. If we were to do that, it would print the address in hexadecimal. So if you don't know hexadecimal, that's okay, but that's just how it prints the memory address. So if you've heard of that before, then you can kind of take a look at that and see what that's doing. But if not, that's okay. It's just the memory address. So it prints the memory address. So we talked about reference variables before, so hopefully that makes sense. Okay, so a pointer variable is going to hold the address of a variable. So it points to the address of a variable. Now, we've been working with pointers. We just didn't really say that's what it was. So we've been working with arrays, and arrays are actually pointing to. I don't know why I can't get
started.
Okay. Can y'all hear me? Can you see my screen? Okay. All right. So arrays are pointers, and you just might not have known that, but one of the questions in your review questions was, are arrays passed to a function by value or reference? And it should be by reference, because if you were to change that array and that function, it will actually change the original array as well. And so arrays are done by reference because they're actually pointing to the array. So you're not passing a copy of the values in the array. When you do it, you're actually passing a pointer to the array. And so when you make changes to the array, it actually changes the actual array because it's pointing to the original array. Okay. All right, so if you look at this, if you see when we are saying, okay, we have a show values function, and we're taking in an array, it's named values, but when we're doing it, we're actually passing the pointer of the numbers array. And so if you were to change that in here, it would actually change the numbers array. Everybody with me? Does that make sense? Okay. Morning. All right, so when we were working with reference variables, we were also using a pointer. So when you did something like this, if you had a donuts variable and you put the little ampersand in front of it, what would happen is whenever someone passes something to there, instead of passing a copy, it's actually passing the reference, the pointer. So jelly donuts here is actually pointing to that. And so when you actually enter the number of donuts for this donuts variable, it actually changes the jelly donuts as well because it's pointing to that. So changing this donuts variable because it's referencing the jelly donuts, so it's pointing to it, also changes the jelly donuts. Everybody okay with this? We had already talked about this, but I didn't really call it a pointer. They just call it referencing, but it is a pointer to it. Okay. So it's actually pointing to the address for the jelly donuts. So whenever you change donuts, it changes the jelly donuts as well. So far, so good? Okay. So we use pointers, with arrays and with reference variables, but we can also set up a pointer variable that we can use. And we can use that the same way we use arrays, for example. So we'll walk through that and show you how to do that, with an array, so you can see the difference. But when you want to define a pointer, you're going to put the little asterisk in front of it. And so you can actually write it with a space. It doesn't matter. You can put the asterisk with the space. You can put it right next to the data type or right next to the variable name. It's okay either of those ways. But this INT-PTR stands for pointer, int pointer, and it holds the address of an int. So whenever you're doing it, it can point to an integer. It has to point to an integer, though it can't point to another data type. So whenever you define the data type, it has to be pointing to that data type, otherwise it won't work. Okay, so in this case, you have a pointer called int pointer here that's pointing to an integer. And then if you put a reference variable in there, it'll get the address of that reference variable num, and it'll put that in your pointer. So it'll point to that reference variable num. Whenever you want to initialize a pointer at, you just want to start it off just like we have null, and sometimes we put 0 in there. We can start it off at null pointer, and it represents the address of 0. And so instead of putting 0 in there, we put null pointer, abbreviated like this, and that gives it the address of 0. So if you want to just initialize it with 0, an address of 0, this is how you do that. Okay, so here's an example of a program. You have an X variable, which is 25, and then you have a pointer, which is called PTR for pointer. It points to an integer. It set it as a null pointer, which gives it the address of 0. And then if you put ampersand X, that gives the reference location, this variable, the memory location, and it saves it in pointer. So that whenever you go to print that, if you print X, you're going to get the value of X. But if you print the pointer, you'll get the address of the pointer, whatever X is located at, since that's what you put it in there as the value for the pointer. So you put the ampersand X, so you get the memory location for X. So when you print it off down here, this is a memory location, this 0x7e00. You don't have to understand that, but just know that that's a memory location. Okay. Everybody with me so far? Okay. So whenever we're doing it, if you put the asterisk, I know this seems strange because when you declare the pointer, you put the asterisk in there to say that it's a pointer. And then you can, for example, point to X by putting the reference, the ampersand in there to say that you want to reference X. And it will actually put the memory address of X inside the pointer. But if you want to print the value of the pointer, what it's actually pointing to, when you do a cout, you put the asterisk again and it prints the value. If you take the asterisk off of there, it prints the memory location. So if you see on the previous slide, if you don't put it with the asterisk, then you get the memory location. And if you put the asterisk on there like this, then it prints the value that it's pointing to. So the asterisk gives you the value it's pointing to, and with the asterisk gives you the memory location. It just takes some getting used to. If you do the wrong one, then you can easily just add the asterisk or take it off if you forget. Okay, so here's a program where you can see, the contents of this shows X. This is the same program. So X is 25, so it's going to print 25. You have a pointer variable that's taking the memory location of X. And then down here, instead of saying PTR, which would print the memory location of the pointer, what it's pointing to, if you put the asterisk, it'll give you the contents of what it's pointing to. So it'll also display whatever is in X, which will be the same thing that was right above. Okay. And then this one will assign 100 to the what it's pointing to, which is X. And then it'll display the content. So it actually changed X and what it's pointing to. And so you can see here, it's 25 at first because X was 25. And because you have the little asterisk here, it shows you what it's pointing to instead of what the memory location is. And then here, when you change it to 100, then it also changes. And because you have this little asterisk, it shows you what it's pointing to, which is X, instead of showing you the memory location of the pointer. So remember, if you put the asterisk in the cout, then you get what it's pointing to. And if you take it out, you get the memory address of it. Anybody have questions about that? Okay. So you can easily also list an array with pointers, using pointers, because remember that an array is using pointers. And so it's just another way to write it. So if we were to have this vals array, it has a value of 4, 7, and 11. Then if we were to say something like this, vowels, it would actually print the memory location. And if you say vowels and you give it an index number, it'll print whatever value is in that particular index number. So in this case, 0 is the first one, which is 4. So this should be review. And then I'm going to show you something with a pointer. If you were to do an array, vowels, you can also use the pointer. Now, when you use the pointer, it's going to display it actually is going to the first value in the array. So if you were to do this, remember this is going to show you what it's pointing to. So what is the vowels array pointing to? The first value always points to the first value first, which is 4. So if you were to do asterisk vowels, it would point to 4 and it would show you 4. Remember, if you do vowels without the asterisk, it shows you the memory location. You can also save an array as a pointer. Okay. So here you can see that you have an array with 10, 20, 30, 40, 50. It's called numbers. And if you want to show the first element of the array, if you show what the array is pointing to, which is you put the asterisk here, then it actually shows the first value. Remember that if you take that off, it shows the memory location, but if you put the asterisk, it'll show the first value it's pointing to. Okay, so how do we get to the other values if we can only show the first value by doing the asterisk? Well, what you can do is you can actually say that, put the asterisk here and just see the name of it +1 or +2, and it'll skip to the next value in your array. Okay, is everybody okay with that so far? Okay, let me know if you have any questions. All right, so you can see we're used to this, doing this. If we wanted to put the number 17 into index location 2 in an array, then we can do that. Or the pointer, it can also be done like this. It can be done with the vowels pointer. And if you wanted to put it in the index location 2, you just put +2. Okay. So this is equivalent to this if you wanted to write it like a pointer. So if you're used to working with this with a loop, and this I would be your index that moves through the loop, for example. So you usually use a for loop and you start at 0 because arrays start at 0. And then you go until the length of your array. And then you usually count by ones, and you usually call it I because I stands for index. But if you wanted to, you can use the pointer name or the name of the array with an asterisk and then put +I, and this would do the same thing. Because remember that your array is really just using pointers, so you can also just use the name and use this way. It's a different way of writing it. Okay. So we have an array in this one that has 5 values, the 5 values in the coins array. And then we have a pointer that's going to point to a double. And then down here, we're going to have a for loop that looks just like our for loops before. It's going to go through the number of coins in your array. And then here is a way to write it like we would write it before with the array and the counts variable. And then here is a way to write it as a pointer. So you would use this, the name of the array, and then you would put +count here with the asterisk. So you can switch them up. You can use the pointer, you can use the array name. They're both okay. And you can use the asterisk, you can use this notation or you can use this notation, and they both work the same way, basically the same thing. So that's what that's showing you. The same values twice, just 2 different ways. Okay. You can do arithmetic with pointers. So you can actually, add or subtract. So you can do plus for the pointer. You can do minus. We've already seen this one. This one is how you actually move through the index of an array. So you can take the pointer and add 2 to it, and that'll get you to index location 2 in the array. and you can put a value in there that way. You can do the plus, you can do the plus equals, you can do minus equals. You can't do multiplication with or division with pointers. So just addition and subtraction. But that's how you move forwards and backwards in the array. So you can increment the actual pointer or decrement it, go forwards or backwards, or you can increment or decrement the value that you're working with. Okay, so in this example, we have an array and we have a pointer called num pointer. And when we go down here, this is our typical for loop we use to go through an array. And what it's going to do is it's going to tell you those numbers. And instead of actually doing the way that we had it written before, the notation we had before, it has a plus plus here to increment it for you. So it'll move to the next one. Remember, if we do the asterisk, we get the value. If we take the asterisk off, we get the memory location for the pointer. And we increment it down here instead of putting +1 up here. And then this one just goes backwards. So you can see you're just starting and subtracting and then printing it and then subtracting and printing it. So this one goes forwards 5 through 40 and this one goes backwards 40 through 5. Okay. So whenever you're initializing your pointers, you can, we had already shown this, you can put a reference variable in there to get the value. You don't want to mix data types. So like if you had a double cost here, you're going to see that this is going to point to an integer. And then when you put the reference variable cost in there, you put the memory location for cost. That's not pointing to an integer, it's pointing to a double. So make sure that whatever you're pointing to is the same data type. So this would have to be double down here or int up here. You can't have one variable that's a different data type and then try and point to that with a pointer that doesn't point to that data type. So your pointer has to be pointing to the right data type. You have to set up the same data type. You can test for an invalid address. You can say not the pointer, and I'll tell you if you have an invalid address, because remember that using it without the asterisk gives you the memory location. You can compare pointers by using equal equal. So comparing addresses without the asterisk, with the asterisk compares values. So if you want to know if it's the same memory address, then you use it without the asterisk. If you want to know if that pointer points to the same value, then you use it with the asterisk. Okay. You can use it as a function parameter. So just like you can pass an array, you can pass in a pointer. You just put the data type and then you put the asterisk signifying that it's a pointer. Okay. And then when you want to take in data, if you put the asterisk, then that's going to change the value of what you're pointing to. Okay, so for example, this is a call to the get num, which you had up here. This would pass in like a reference variable, for example, and that memory location would go to this pointer. Okay, so just another example. Whenever you're doing a swap, you have to be careful. You have to keep track. So if you think about swapping something, I skipped this because it really wasn't part of the class, but if you go on to more advanced class, you'll talk about different types of sorts. And in your book, it talks about different types of sorts. If you have extra time and want to read about it, it would be great, but I know you're all busy right now, but you should still have access to the book for a while. You can read about it after the course ends. So you can swap variables, but you have to be careful because if I were to see, put this variable in this one's location, then it wipes that one out. So you have to have a temporary variable to hold the place of the other one before you actually swap them. So just like, you know, if you were to say flip two values, when you put one value in the place of the other one, you're wiping it out. And when you go to put it back, you don't have it anymore. So you have to save in a temporary variable, then swap, then take the one from temporary back into the variable that you swapped with. And so it's kind of a different concept to get used to. And your book does go through in the array chapter. There's a chapter after that that we skipped that you could read over, chapter 8, that talks about the different types of sorting and searching. And so if you have extra time, it would be probably good to look over that and see what that's all about, because it would be useful if you're going on to coding in the future. Okay. So here's an example of the prototypes. If you're writing it in a function, you just put the asterisk there. You don't put the variable name. And then when you're actually going to create it, which is in the next slide, here, you actually put the variable name. So here we have a pointer named input that's going to point to an int. Here you're going to take an integer and you're going to point to that. Okay, so if you go back here, you have a reference to number here whenever you call that. So you're passing in that pointer, that reference to number. I'm sorry, it's on two separate slides. And then this one also takes in okay. If you can use constants, so you can point to a constant. So this one, for example, has a size of 6, is a constant, and then this one is an array, that's a constant. And so you can do a constant, a pointer that points to a constant variable, which is a double in this example. So you just put const, and this rates variable would point to a double that's a constant. Okay. Constant means it doesn't change. Okay. So this is what it points to, and this is the variable name here. So there's a little difference between pointing to a constant and the pointer being constant itself. So the pointing to a constant means the value can't change. The pointer being constant means the memory location can't change. So it's just a different way of writing it. Can't point to anything else if you do it this way, and the other one means the value can't change. So it depends on where you put the word constant. This one means you're pointing to an integer, but this pointer can't change what it's pointing to. Has to keep pointing to that, and then the other way around means that the value can't change. Okay, so it's just written a little differently. I think the notation just takes some getting used to. I think I just did this one, sorry. All right. So dynamic memory allocation, I believe we've done this before. So whenever let's say you wanted to get a list of scores, you can ask the user for how many scores they have as a variable, and then you can create your array based on that variable number that they type in. So that's called dynamic memory allocation, because you don't really know how many scores they're going to type in that they want. And your array size is based on how many scores they type in that they want. So you can create an array based on the size that they type in, and that variable creates the size of your array. But you don't know that when you actually, before you run the program. So when you run it, if you're allocating memory at runtime, that's called dynamic memory allocation. So you have to be careful with it, because you don't want to have like memory leaks or anything like that. So you have to do some extra things when you're doing that. Okay, so whenever you're creating, this is a pointer example, but we'll have an array example soon. So, all right, so this one is a pointer, and whenever you see that use this word new here, then you're actually going to allocate memory for the pointer, and you do that, it's dynamic. So if you look at this example, so you are actually going through and it could have problems because if there's not enough memory available, then you can have a memory leak. And so you're going to have to use a special command called delete if you're doing dynamic memory allocation. So you have to be careful whenever you see this word new, you're actually doing dynamic memory allocation. And there's something called a heap out there. It's like the active memory. And whenever you put things on there, it's possible that you could have trouble because if you don't have enough memory, then cause your program to crash. And so you're going to have to use this word delete to release it. And so if you're working with an array or a pointer that you created for dynamic memory allocation, you want to use this. Now, if you don't use it, it could still work, but it could maybe run out of memory. So that would create a memory leak and that could cause problems with your program. So you want to try to remember to use this delete for your pointer, for your array, because it could cause problems. And so I believe it's on the next one. So on this one, we have, there's 3 slides here. Here's the delete, you have to delete it. So here we're asking them for like the number of sales, days of sales. And here's the number that they're putting in. And then you're creating an array here. This is what I was talking about before. You're creating an array based on the number of days. So if they say they wanted to enter 100, then this array would be created with 100 values. But if they say they want to enter 5,000, then this would be created with 5,000. And so it's dynamic because it happens whenever you're running the program. You don't really know how many they're going to enter. It's based on this actual, oops, let me go back here. It's based on this C in here with the number of days. That creates your array here. And then you enter all of the different sales for each of the days. But the problem is we don't know how large this array is going to be until we run the program and the person enters the data. So what we want to do at the end is a little delete here to free up the dynamic allocated memory so that you don't have any trouble. Now, you might not have any trouble if you forget to put that line, but it's just good programming to try to put that in there just in case that you run into problems. So if you're doing a lot of that, then you could have problems with it, but you may not. So okay, so this one only has 5 values and it enters the values. And this is just like a typical array program that we've been doing before. But the problem is that this is dynamically allocated because we don't know how many number of days that the user is going to enter. And so it's good to do this delete here to be sure that that still works. Okay. Just like you can pass pointers into a function, you can return them as well. And so you can say here, this is a get random numbers function. And you can just say here, return whatever you're doing at the end. And so here, we're checking to see if the number that's coming in is 0 or negative. And then here we can return a null pointer if it is, so that we know that that number wasn't a valid number. Okay, and this is generating a random number. Here, we used this a while ago. And then this is going to get the array with random numbers. So it's going to generate a random number, put it into the array. Okay, so if the number that they entered for how many random numbers they want is less than 0 or equal to 0, then we're going to return null pointer. Otherwise, we're going to generate some random numbers and put them into our array. And then we're going to return the pointer to the array that we have instead of, you know, I mean, that is doing the same thing because remember an array is a pointer. So when you return ARR, that's the pointer to the array. If instead of doing the delete at the end with whenever you're doing dynamic memory allocation with pointers and arrays, you can use something called a smart pointer. And so you have to add a little bit more code. So you have to add this header at the top. And then when you're working with the pointer, this would be the unique pointer like this. Name of the pointer, so PTR. And this is how you set it up for dynamic memory allocation. But it's going to handle the delete for you. The smart pointer is going to handle the delete for you. Okay. And then this is what type data type you're pointing to. Okay, so here's an example. You have to have this new header at the top. Here's the smart pointer here, this unique pointer. Okay, and the name of his PTR. So here you can assign what it's pointing to, a value of what it's pointing to. So 99 is what it's pointing to. And then here you can display it, but you don't have to use the delete. So this program is just to show you don't have to use the delete because you use the smart pointer. Okay, so I want to show you a program. Wrong class. I want to show you this temperature program. Could do it in here, but I have this. It's set up and it's a little bit larger and everything in here. Maybe it's a little too big. Okay. So better maybe. Okay. All right. So here's a program that just shows you how to do the temperatures with a pointer. So it says, how many temperatures would you like to enter? A number of temps, num temps is how many temperatures you want. It creates an array based on that. And then here, use a pointer of nums. And so down here, you have the option. You can do it like this when you want to actually enter the temperatures this way. But this will be the same as, when we did it like this with the nums with the square bracket. So you can continue to do that, but you should know that an array is a pointer. So it can work like this if you wanted it to. It's just pointing to each of the different index locations. And so I is the same as before, except this is just written a little differently. And then so here it asks you to enter the temperatures. And then here it repeats the temperatures and adds them all together. And at the end, it gives you an average because it takes the sum that it was collecting here and it divides it by the number of temperatures. So the only difference is showing you this versus doing it like this, like we were doing before with the square brackets. So it actually functions the same way. It's just interesting to see. I'm just going to put a small number so we don't have to put too many temperatures. Right? And so it's just interesting to see it written that way. So just know that arrays are pointers, and that's why they work differently when you pass them to functions. And I know a lot of students were asking about that because arrays are passed by reference, meaning that they actually will change the original array because it's just pointing to it. So anything you do to that array changes the original. Okay, so I wanted to go to Kahoot and see how this is all making sense. So y'all could join my Kahoot with me. All right, let's get started. And if you're still working on joining, you'll see the game pin down at the bottom so you can still join. Okay, good job. So pointers are designed to hold addresses. Good. Constant just means not going to change. Final is a word we use in Java for not going to change. And location, there's there's local variables, but not location variables. Okay, so pointer. Okay, good job. All right, so if you remember that program that I just showed you, this is actually dynamic memory allocation because you're entering how many temperatures you would like to enter. And this num of temps determines how large this array is going to be. So it's not like we established the array was going to be 5 temperatures in the very beginning before we ran the program. This is established once you run the program. So when you run it, I can enter 1,000 or I can enter 10 or I can enter 5. Just depends on what I enter right here. What I enter here determines what this is going to be. And that's called dynamic memory allocation. Now you also see, I forgot to mention this, but you see how we're deleting that, deallocating that memory. So we should try to do that. If we don't, it's usually okay, but you should probably try to remember to do that because that could cause problems in your program. Okay, so if you're going to do this, you should probably try to remember to do this as well. Okay. Over here. Good job. Okay, wow, good job. So yeah, null is the address of 0. A pointer that contains the address of 0 is called a null pointer. Okay, good job. So it's just getting used to the writing of it. So if you're pointing to a constant int, the data type and whether it's a constant comes first, if that's what you're pointing to. If the pointer is a constant, then that would come before the variable name pointer. Okay, so if it comes first before the data type here, then that's what you're pointing to. Otherwise, it would come before the name of the pointer. Okay, good job, guys. So remember this program. This is the one we're just talking about here. And so same thing here. So delete is that keyword. Okay, let's see how we did. Okay, good job, guys. All right. All right, so what I want you to do now is I have a couple problems for you that I want you to work out while I'm taking attendance. I'm going to bring up on the screen here. I want you to try to solve these. It's going to help you see if you understand the chapter. And then we'll go over them together and see what you came up with. but I want to take attendance while you're doing that. So go ahead and see if you can solve those